This study is about water pollution and how the dyes from industries like textile, paper, rubber, plastic, food, leather, and cosmetics play a major role on it, and how to abate this problem as chemical engineers. To give some perspective, a life cycle of one t-shirt production pollutes around 2,700 liters of water. A big part of that pollution comes from dyeing, which are the coloring of these fabrics. Most of our clothes, if not all, are dyed using synthetic chemical dyes. What's even more shocking is that, on an average, any synthetic chemical dye holds between 8,000 to 15,000 different inorganic compounds. These compounds not only pollute our water, but also damage our skin. If we think this pandemic is bad and something that will probably last 2 or 3 years, think about the long-term severe environmental impact on our water systems, which will last for generations. So, what is the solution? Here is the solution. Hello, my name is Inas Al-Barami and my co-researcher is Rawan Baqwer from Department of Chemical Engineering, University of Technology and Applied Sciences, Salalah, Sultanate of Oman. A very good day to one and all. We are here today to present our research work, which is on application of artificial neural network, ANN, and response surface methodology, RSM, of dye removal by a novel biosorbent, under the guidelines of Dr. Rakesh and Ms. Erlin. These are the outlines of our presentation. As we observed in the initial part of the video, industrial effluents from various industries have a complex nature of pollutants, including organic and inorganic substances. Therefore, there is a need to find various types of treatment techniques before releasing into the environment, with the acceptable limits, as well as to find an economical and environmental friendly techniques. Let's have a general introduction on methylene blue dye. In this research, we did experiments on biosorption of methylene blue dye effluent by the use of biosorbent as banana leaf powder. Methylene blue, or MP, is a heterocyclic aromatic chemical compound with the molecular formula C16H18N3SCl. This dye is important and basic dye which is widely used for the coloring of paper, textiles, sometimes used as a hair colorant, and it's also used for medical purposes. When this effluent released into nearby water bodies, it will cause a lot of damage in the food chain system. Especially, it will have a lot of impact on aquatic animals that present in the water bodies. If we see the aim and objectives, the aim is for the removal of methylene blue by a use of biosorbent. The main objectives of this present research are optimization of process parameters by RSM and modeling by ANN. Here we have various types of treatment techniques available in the literature, starting from preliminary to tertiary treatment techniques. After studying the advantages and disadvantages of the previous treatment techniques, we found that the biosorption, which is carried out using naturally occurring materials, is an efficient and economical method for the dye removal through the porous surface of solid, which is called biosorbent. Here you can see the advantages of biosorption and the factors that affecting it. Regarding the methodology, initially the waste banana leaves were collected near Salalah, Dhofar region, Sultanate of Oman. Leaves were washed with the ionized water for several times to remove the dirt particles. Then, methylene blue solutions were prepared by dissolving its corresponding salt in distilled water. The pH of solutions was adjusted with 0.1 normality, HCl, and NaOH. Later, an UV spectrophotometer was used for the determination of methylene blue concentration. The effect of agitation time with different interval concentration of methylene blue was studied by agitation of 30 ml of different concentrations of dye solution with 0.1 gram of adsorbent the size 75 micrometer at 180 rpm for 1 hour. At the end of the predetermined time intervals, the sorbent was separated by centrifugation, and methylene blue remaining in the solution was analyzed using UV spectrophotometer. After the end of the experimentation, we have calculated the dye uptake Q. In order to obtain the optimum condition for the percentage of methylene blue removal, 4 independent parameters were selected for the study by the use of RSM, where the RSM is a statistical method that uses quantitative data from the related experiment to determine the regression model and optimize the response output variable, which is influenced by several independent variables, which are input variables. The shown method is commonly preferred due to its simple algorithm and high training capacity. Backpropagation network algorithm consists of 3 layers, namely input, hidden, and output. The number of hidden ANN layers can be increased depending on the essence of the problem. MATLAB software package was used during the ANN calculations. In the percent study, the relationship between 4 independent variables and percent of methylene blue removal are fitted well with quadratic model. The quadratic regression model for percent of dye removal obtained from CCD design in terms of coded factors is presented as shown. From this table, the percentage of methylene blue removal from aqueous solution response value was in the range between 49.12% and 75.82%. The ANOVA of this model was significant, with model F value of 718.5. The non-significance error explained that the quadratic model was valid for the present work when it was more than 0.05. The predicted optimum conditions with 75.86% of methylene blue removal at temperature of 39.4 degrees centigrade, pH of 5.8, biosorbent dose of 0.27 grams, and initial dye concentration of 53.07 milligrams per liter. This party plot shows the relation between observed and predicted value suitability. The methylene blue ions biosorption capacities of the present biosorbent over different combinations of independent variables were visualized through 3-dimensional view of response surface plots. The plots were represented as a function of 2 factors at a time, holding other factor at a fixed level. All the response surface plots revealed that at low and high levels of the variables, the capacity of the biosorbent was minimal. However, it was noted that there existed a region where neither an increase or a decrease trend in the biosorption capacity was observed. This phenomenon confirms that there was an existence of optimum for the biosorption variables in order to maximize the methylene blue biosorption capacity. As shown in the figure, training, variation, and test data of the ANN model that provided the best prediction. Moreover, statistical performance of the model was assigned by using the statistical parameters of mean, mu, standard error, SE, standard deviation, sigma, and regression coefficient R-square. The relationship between the prediction results of the designed ANN model and experimental data were organized so as to evaluate the success of the ANN modeling, which used as an effective tool. According to the graph for minimum mean squared error versus the number of epochs for optimal ANN models, shows that there is no significant change occurs on the method's performance after 27 epochs. Best validation performance is 0.0011846 at epochs 27. In the end, the response surface methodology RSM gives the optimum process condition for the removal of methylene blue using banana leaves as a biosorbent, and biosorption performance of banana leaves during the removal of methylene blue from the aqueous solution was successfully predicted using a 3-layered neural network with 6 neurons in the hidden layer. So, we conclude that this research shows the economical and eco-friendly solution for the treatment of dyes which are coming from various industries. These are the references that we used for our research. Thank you so much, Abu Dhabi University, for providing us a platform for showing our research to the society.